The Salt Legacy. The Universal Condiment, a Natural and Social History of Salt. Chapter 1. The Molecular Foundation. 1. The Chemical Marriage, Sodium and Chlorine. To understand the legacy of salt, we must go small, impossibly small. We must step into a world invisible to the naked eye, a world where two of nature's most dangerous elements are about to do something remarkable. Two elements, both deadly on their own. Together, they will create the foundation of life itself. Let's start with chlorine. In its pure form, it is a pale, greenish-yellow gas, heavy, thick. It carries a sharp, stinging smell, nature's own warning label. This is an element so toxic it was once used as a weapon of war. It is restless, it is hungry, and it will corrode almost anything it comes into contact with. Now, meet its partner, sodium. This is a metal that breaks every rule we think we know about minerals. It is so soft you could slice through it with a kitchen knife. Cut a fresh piece open and it gleams with a cool silver light. But that shine fades almost instantly. The moment air touches it, it dulls. And beneath that calm, quiet surface, there is something violent. Place a small piece of sodium into water. Watch closely. It does not sink. It skitters across the surface, hissing, spinning, catching flame. A pale yellow fire that flickers and dances as it tears hydrogen straight out of the water. This is an element of fire and fury. So unstable, scientists store it submerged in oil just to keep it from igniting on its own. Fire and poison. And now they collide. When sodium meets chlorine, a burst of energy erupts between them, a chemical heat. And in that single violent flash, both elements surrender completely. Their old identities gone. The fire disappears, the poison fades. What emerges is something extraordinary. A white, a calm, a perfect crystalline solid. Sodium chloride. Salt. It does not burn, it does not suffocate, it simply sits, serene and stable in the palm of your hand. From two agents of death, the universe has built something life cannot exist without. Without salt, your blood cannot carry oxygen, your nerves cannot send signals, your muscles cannot move. This is not just a fact of chemistry. This is the opening chapter in one of the oldest stories on Earth. 2. Crystal architecture. The geometry of the cube. If the meeting of sodium and chlorine is a marriage of fire and gas, then the crystal they form is their frozen monument. Hold a single grain of salt up to the light. Now look closer. Under a microscope, something extraordinary happens. That wild energy of those two elements, gone, replaced by perfect order. Every line is straight. Every edge meets at a right angle. Every face a flawless square. Nature's blueprint for salt is the cube. When salt water evaporates slowly, undisturbed, unhurried, the molecules stack themselves with stunning precision, layer by layer, face by face. The crystal grows into a small, transparent block of light. But that solid shape is a trick of the eye. Inside that perfect cube, the structure is far more intricate than it appears. 6 hollow pyramids, each tapering inward, their tips meeting at a single invisible point, right at the center. A hidden cathedral inside a grain of sand. Now, watch what happens when this quiet process is interrupted. In the great salt pans, where fire pushes the brine to its breaking point, something strange begins to form on the surface of the liquid. Not solid blocks, something far more delicate. They're called hoppers. A hopper crystal starts as a tiny square, a single floating raft of salt. But as more salt builds around it, something unusual happens. It does not fill inward. Instead, it grows upward and outward along the edges only, layer after layer, step after step. The result is a miniature stepped pyramid, like something carved by ancient hands, floating silently on the surface of the brine. These hoppers are so light they stay afloat, until their hollow chambers fill with liquid, and then, quietly, gently, they sink, settling on the floor of the pan, joining the harvest below. Whether it is a massive block carved from the deep galleries of an underground mine or a tiny grain on your kitchen table, the cube is the fundamental shape of salt. Even in the most ordinary substance on Earth, there is an invisible law at work. 3. The physics of brine, saturation and solubility. When salt meets water, the rigid geometry of the crystal dissolves into something else entirely, a liquid partnership of immense power. It is called brine, a fluid that has carried the wealth of nations, that has fed armies and preserved empires. But the science behind it reveals something stubborn about salt, something almost defiant. Unlike sugar, which dissolves more and more as the water heats up, salt barely cares about temperature at all. 100 parts of cold water will accept about 36 parts of salt. Heat that water to a boil, and how much more will it take in? Only 4 parts more. That is it, from 36 to 40. Nothing else. This near-constant behavior is a genuine anomaly in chemistry, and it changed the course of human industry forever. Because it means one thing clearly. To harvest salt, you cannot simply cool hot water and wait for crystals to appear. You have to drive the water away, slowly, patiently, through evaporation. And as fresh water becomes brine, everything about it changes. It grows heavier, denser, more viscous. It pushes back against the body in a way ordinary water never could. Float in the waters of the Dead Sea or the Great Salt Lake, and you will feel it. A liquid mattress holding you up without effort. Salt also changes how water behaves under heat. Pure water boils at 212 degrees Fahrenheit, but a fully saturated brine, it holds on longer. It refuses to boil until it reaches 225 degrees or more. And in the northern freezing cold of the northern winters, salt reveals another secret. When salt water freezes, the ice that forms is nearly fresh. The salt is pushed out, squeezed into the remaining liquid, making it even more concentrated, even more potent. Whether it is the thick liquid left behind in a salt worker's pan or the vast hidden oceans beneath the plains of Cheshire, brine is the starting point, the liquid precursor to everything solid. It is, in many ways, the same fluid that runs through our own veins. 4. A spectrum of impurities, colors of the earth. In its purest form, a salt crystal is perfectly clear, a transparent window that light passes straight through. But in the real world, salt is rarely that clean. As it forms deep underground over millions of years, salt absorbs the minerals around it. It collects the secrets of the earth, and in doing so, it becomes something visually stunning. The earth, it turns out, is an artist. The most famous example is found in the Great Salt Range of Pakistan. Here, the salt glows. The underground galleries of these ancient mountains are filled with crystals that range from a soft, warm pink to a deep, rich crimson. The color comes from tiny traces of iron oxide, the same rust that paints the surface of Mars. Step inside one of these caverns. Let the light hit the walls. The entire space seems to blush, warm, alive. It feels less like a mine and more like the inside of something breathing. Now travel west to the mines of Wieliczka in Poland. Here you will find something rarer, sapphire blue salt. These crystals are among the most prized specimens in the mineral world, but their color is not caused by a chemical dye. It's an optical illusion created by tiny structural shifts inside the crystal itself. These shifts scatter the light in a specific way. Only the deepest blues and indigos reach your eye. It is a blue as deep as the midnight ocean, and yet it's a ghost. Grind this blue salt into a fine powder, and the sapphire vanishes completely. All that remains is ordinary white dust. Elsewhere, the earth offers darker, more somber tones. In the salt regions of Cheshire and the mines of Hallstatt, crystals are veined with yellow, brown, and jet black. These colors come from ancient clay or from organic matter trapped millions of years ago in a drying lagoon. In rare cases, traces of petroleum in the rock give the salt a dark, smoky appearance, as though it were forged in the soot of a primordial fire. Every color tells a story. Every streak, every vein, every shade is a record of the exact environment where that salt was born. To study the colors of salt is to read the diary of the earth itself. 5. Hygroscopy. Salt's interaction with the atmosphere. Salt has a secret, a hidden, almost instinctive relationship with the air around it. It is called hygroscopy, and it is the invisible thread that connects the solid mineral to the living atmosphere. To most people, salt looks dry, stable, inert. But to a scientist or a salt worker, it is anything but. Salt is always breathing. Now, pure sodium chloride on its own is actually quite indifferent to moisture. It could sit in a damp room for years without changing shape. But that is not how salt exists in the real world. In nature, salt almost always comes with company. Two particular companions, magnesium chloride and calcium chloride. And these impurities are fiercely thirsty. The scientific term is deliquescent, from the Latin meaning to melt away. These minerals have such a powerful appetite for water, they will pull moisture directly out of the air, silently, invisibly, until the salt grain can no longer hold its shape, until it dissolves right before your eyes into a shallow pool of brine. For centuries, this behavior made salt one of humanity's oldest weather tools. In the damp cottages of coastal Britain, a bowl of salt on the shelf was all a family needed. When the grains grew heavy, when they clumped and stuck together, it was a warning. The air pressure was shifting. Rain was coming. In the dry deserts of Africa or Spain, that same salt could stay sharp and crisp for hundreds of years, because the air there has no moisture left to give. This creates a constant battle in the salt industry. In the great storage halls, the mineral must be guarded carefully. One humid night left unprotected, and thousands of tons of salt could begin to weep, dissolving slowly at the edges, flowing away in thin, salty streams. And yet, this very same sensitivity is exactly what makes salt so essential to our own bodies. Inside the human body, a warm, humid environment, salt keeps our tissues hydrated. It regulates the fluids around our cells. Without it, they would slowly wither. As we close this first chapter, one thing becomes clear. Salt is not a passive, silent rock. It is a chemical union of fire and gas, a masterpiece of hidden geometry, a living record of the Earth's history, and a quiet guardian of the atmosphere itself. It is this rare combination of properties that carried salt out of the geological deep and into the very heart of human civilization.